Hello and welcome to Utkarsh Minds Python for Data Science. Today we will see a very important topic, how to implement a hypothesis testing on ordinal variables. So we have two variables, one is ordinal and we want to see whether it influences another variable that is also ordinal. Since we are working with Python, I will open my Colab notebook, then click on new notebook. As the new notebook opens, I will give it a name ordinal and click on connect and upload my data set. The data set is same student statistics. Okay, so uploading student statistics. Make sure that the notebook is connected, then import the necessary libraries. One is NumPy, one is the pandas library, and finally we need the matplotlib library. All the three libraries we have, we will read our data set. The student statistics and semicolon. So we can also use the head command and display the first 5 rows of the data. Mainly we are interested in two ordinal levels. The first ordinal variable is known as teach underscore motivate. So it is whether the teacher is able to motivate you to study. It has fully disagree, neither disagree, agree and fully agree. So many levels. The second variable is link theory, whether the teacher is able to link theoretical concepts with practical implementation. So again, neither disagree, fully disagree, agree and disagree. So these are the feedback given to the teacher on two parameters. Number one is to create a cross table so that we can visualize whether the what is the distribution of data. So first we take our variable teach motivate and then we take our variable teach link theory. Okay, that gives us the cross table. We will store that in a variable called data viz. Then we can also plot this data visualization so that we can get a bar chart. See, you have got a bar chart of the levels. Link theory is the legend and x-axis is teach motivate. Next comes the statistical test and the effect size. So we are having the null hypothesis that says no relation between the teach motivate and teach link theory. So there is no association between these two ordinal levels. And the second one is saying that there is a relation between these two. And then how strong is that relation, if at all it exists, comes from the effect size. The test that we will be using is known as the Goodman-Kruskal gamma test, and the effect size is known as the gamma effect size. The implementation of this test and effect size is not straightforward, so I will directly give to you the function for calculating this effect size and test. There is a function which is available on internet on calculating the Goodman-Kruskal gamma. It takes the data set, the two ordinal columns and the coding scheme for the two ordinal columns, and then it returns multiple things. First it will return the Kruskal value, the interpretation of the effect size, the Z value and the P value, multiple things. So let us see how this function can be called. We have to first understand what are the different levels present in our ordinal data. So let us see. Teach, motivate first, and what are the unique values, and then we see the teach, link theory, and what are the unique values in that. Okay, so null values we will discard. The ordinal variable 1 I will call this, and I will pass the list of values in order. So there is fully disagree, then there should be neither disagree, which is the third level. Fourth is agree, which will come fourth, and fully agree is the fifth. Okay, so these are the 5 levels for the first ordinal variable. Similarly, the second ordinal variable also has the same levels, so that is good sign for us. And finally, I will call my function. The function is having the name Goodman-Kruskal gamma. So Goodman-Kruskal gamma function will take the data frame first. Names of the columns. The first column's name is teach, motivate, and the second column's name is teach, link theory. Finally, it will also take the ordinal variable 1 and the ordinal variable 2. So these are the levels in the right order for the two ordinal variables. Then what does it return? Number 1, it returns the statistic, gamma statistic, and its interpretation. So this is our effect size, which is very strong. And secondly, it returns the p value. So it has returned 3 p values. We are only interested in the third one in the list because these all are calculated in very different manners. Our p value is e minus 40, that means 10 raised to minus 40. Remember, this is e notation in Python. E raised to minus n is 10 raised to minus n, which is very less than 0.5. If you want, you can have a if else, that if p value is less than 0.5, then we print result is significant and null hypothesis is rejected. Else we can print that result not significant and null hypothesis cannot be rejected. We see that result is significant and null hypothesis is rejected, plus the effect is very strong effect. Finally, our report will say that the two variables have, that is teach, motivate, has an impact on teach, link theory as per the result of Goodman-Kruskal gamma test. Here I will report my p value, which is, no need to report it exactly, but it is less than 0.5. and further the impact was very strong. So this is my gamma, which is equal to 0.87. That means in layman term, if a teacher is able to motivate, then it is having an impact on the variable. Teacher is able to link theory with practice. So you can say that a teacher that is able to motivate is also able to link theory with practice. That means this variable 1 motivate has an impact on the second variable link theory. Thank you for watching, and keep practicing this program so that you can apply this same analysis on other data sets. Take care and see you in the next video.